Hi, today we are going to see about Maxwell equations. James Clerk Maxwell, Scottish theoretical physicist and mathematician. The achievements of Maxwell: the development of the classical electromagnetic theory, synthesizing all previous unrelated observations, experiments, and equations of electricity, magnetism, and even optics into a consistent theory. Maxwell equations: del cross H vector equal to J vector plus dou D by dou T, del cross E vector equal to minus dou B by dou T. Maxwell equations are generalization of all electrostatic and magnetic phenomena known before. Maxwell equations express the inseparable relations between electric and magnetic fields. From Maxwell equations come directly law of energy conservation, law of charge conservation, electromagnetic waves existence and propagations proved by Hertz in 1886. This is the electromagnetic waves. In this, electric field and magnetic field are perpendicular each other. Electric field E vector and magnetic field H vector. This is the wave propagation direction. This is wave propagation. This is line of sight propagation. There are two towers. Each will be contacting with each other. Maxwell equations are the basis of electromagnetism. Del cross H vector equal to minus J vector plus dou D vector by dou T, and del cross E vector equal to minus dou B vector by dou T. These two equations and additional 6 equations form a set of 8 equations fully describing the electromagnetic field. 3 Maxwell's postulates concerning divergence of the electric field: del dot D vector equal to rho, del dot B vector equal to 0, del dot J vector equal to 0. The so-called point equations inform us about the medium in which the field exists. D is equal to epsilon into E vector, B is equal to mu into H vector, or B is equal to function of H vector, J vector equal to gamma into E vector. First Maxwell equation: del cross H vector equal to J vector plus dou D vector by dou T. Differential form of Maxwell equations: rotational magnetic field or vortex field is generated by currents and or by changing the electric field. J vector is the conduction current density. The notion dou D vector by dou T is called density of displacement current. So Jt vector equal to J vector plus dou D by dou T vector. Jt expresses the density of the total current, and J is the density of the conduction current, and dou D by dou T is the density of the displacement current. Integral form of first Maxwell equation: from differential form of Maxwell equation, del cross H vector equal to J vector plus dou D vector by dou T vector. After integration over the surface S with the bound C, we receive a new form. There is surface integral del cross H vector del H vector into ds vector equal to J vector dot ds vector plus in surface integral dou D vector by dou T into ds vector. Stokes theorem. So contour integral H vector dot dl vector equal to surface integral J vector dot ds vector plus dou vector by dou T into surface integral D vector dot ds vector. The order of operations can be changed because the integration over the surface and differentiation with respect of time are independent. First Maxwell equations in integral form: contour integral H vector dot dl vector equal to surface integral J vector dot ds vector plus dou by dou T into surface integral D vector dot ds vector. The line integral limit a to b H vector dot dl vector equal to u that represents the magnetic voltage between the points A and B. Surface integral J vector dot ds vector plus dou by dou T into surface integral D vector dot ds vector. So this surface integral D vector dot ds vector represents the electric field flux and represents the total current, the sum of conduction current plus displacement current. Conduction current plus displacement current. Let us consider the field in capacitor when the electric field changes in time. I is equal to dq by dt, and I is equal to dou by dou T into surface integral D vector dot ds vector. In this, the conduction current flowing in wire is motion of the charges. So I is equal to dq by dt. Changing electric field exists between the capacitor plates. So the electric flux goes through the surface S. So surface integral d vector dot ds vector. Displacement current exists in the capacitor. So I equal to dou by dou t surface integral d vector dot ds vector. A displacement current is the extension of current flow in dielectric where there is no way for conduction current. The rule: the current flows by closed path is realized like this. In wires, a conduction current; in dielectric, a displacement current. So I equal to dou by dou t into surface integral d vector dot ds vector. This current can reach greater values if the field is changing with great frequency. Second Maxwell equation, del cross E vector equal to minus dou B by dou T. This is a differential form of second Maxwell equation. Rotational electric field, vortex field is generated by changing the magnetic field. Integral form of second Maxwell equation. From differential form of second Maxwell equation, del cross E vector equal to minus dou B vector by dou T. After integration over the surface S with boundary C, we receive the integral form. So surface integral del cross E vector dot ds vector equal to minus surface integral dou B vector by dou T into ds vector. Applying Stokes theorem, counter integral E vector dot dl vector equal to minus dou by dou T surface integral B vector dot ds vector, where B vector dot ds vector is the magnetic flux. The line integral from the point A to B, E vector dot dl vector equal to VAB represents the electric voltage between the points A and B. Counter integral E vector dot dl vector equal to minus d phi by dt. This equation represents the Faraday's law of induction. So minus surface integral dou B by dou T into ds vector equal to minus dou B by dou T surface integral B vector dot ds vector, that is equal to minus dou phi by dt, that is equal to E. EMF is induced electromotive force E. The integral form of Maxwell equation. So integral h vector dot dl vector equal to surface integral j vector ds plus surface integral dou d vector by dou t into ds vector. This is conduction current density and displacement current. Similarly for electric field, E vector dot dl equal to dou by dou t into surface integral B vector dot ds vector. First Maxwell equations, Ampere law. So counter integral surface integral h vector dot dl vector equal to surface integral j vector dot ds vector plus surface integral dou d by dou t into ds vector. A magnetic voltage along the closed curve C is equal to the total current. So the sum of conduction current and the displacement current passing through the surface which bound is the curve C. Here second Maxwell equation from Faraday's induction law. So closed curve E vector dot dl vector equal minus dou B by dou T surface integral B vector dot ds vector minus dou by dou T into surface integral B vector dot ds vector equal to minus dou phi by dou T, that is equal to E. EMF induced electromotive force is E. The voltage along the closed curve is equal to the electromotive force induced by time changes of the magnetic flux passing through the surface bounded by this curve. Wave in an ideal dielectric. We will derive the wave equations for the electric and magnetic field from the Maxwell equations. It will be a proof that the electromagnetic field is a wave. Assumptions: consider area is unlimited, consider medium is linear, homogeneous and isotropic. Gamma is equal to 0. It means the medium is lossless. There is no currents and no changes in the considered area. So from this, del cross h vector equal to dou by dou t, dou d by dou d vector by dou t, that can be replaced with del cross h vector into d is equal to epsilon, we already know. So del cross h vector equal to epsilon into dou e vector by dou t vector. Del cross e equal to minus dou b by dou t. We know b is equal to mu into h vector. So replacing with this, del cross e vector equal to minus mu into dou h vector by dou t. Del dot e equal to 0. So del dot e vector equal to 0. Del dot b equal to 0. So del dot h vector equal to 0. Assumptions: permeability is constant. permittivity is constant, gamma equal to 0, rho equal to 0. So del cross H equal to epsilon dou E vector by dou T, and del cross E vector equal to minus mu into dou H by dou T. Let's calculate the rotation of both sides of both equations. So del into del cross H equal to epsilon into dou by dou T into del cross E vector. Del into del cross E vector equal to minus mu into dou by dou T into del cross H vector. We already know del cross E equal to minus mu into dou H by dou T, and del cross H equal to epsilon into dou E by dou T. From the vector identity, del cross A vector equal to del into del dot A vector minus del square A. Similarly, del cross E vector equal to del into del dot E vector minus del square E vector. So for magnetic field, del cross H vector equal to del into del dot H vector equal to 0, H vector minus del square H vector. So here del dot E equal to 0 and del dot H equal to 0. We have received the two equations, two vector functions E of P comma T, H of P comma T, which satisfies the equations form the electromagnetic waves. So this means that there might exist such solutions of wave equation which don't satisfy Maxwell equations. So solutions of E of P comma T and H of P comma T must satisfy condition coming from Maxwell equations. So the three Maxwell postulates concerning the divergence of the field del dot D vector equal to rho, del dot B vector equal to 0, del dot J vector equal to 0, and del cross H vector equal to E by dou E in dou E vector by dou T, and del cross E vector equal to minus mu into dou H by dou T. Thank you.